This is for year 11 reference. We're going to look at question 7 from exercise 2H. So it's the last exercise. So we want to find the value of m such that the pair of simultaneous equations given by these two equations have either infinitely many solutions or no solutions. So infinitely many solutions means both lines are overlapping. It's the same line, so they intersect forever on a graph. So in order for that to happen, they essentially have to be the same line. Do you remember that for to define a line, you either need you need both the gradient and the y-intercept. Okay, so in this case, for two lines to be the same, the grades must be equal, and the y-intercept has to be equal. So your c value has to be equal. Okay. Similarly, for no solution, no solution means they must be parallel, meaning they're tram tracks. So m obviously has to be equal, but c is not equal. Not equal. Okay. If c is equal as well, it means you get the overlap scenario, which we don't want. Okay. So the trick to this question is you've got to make sure you find what your m and what your gradient and y-intercept are for both lines. So you're going to rearrange on your calculator. So if I go on my CAS calculator, let's rearrange it. So 3x plus my equals 5. And I'm going to rearrange it. So I'm going to go interactive, advanced, solve for y. And you can do this by hand if you want. I mean, it's not difficult. Just practice it, okay? And then I want to rearrange the other equation. Why am I rearranging? Because I want it in y equals mx plus c form. So I can read what the gradient and y-intercepts are. Okay. I'm going to go interactive and solve. Okay. So let me double check I've got the right. Yep. And I actually want to solve for y, not x. So I got the wrong answer. Okay. So I'll paste this onto the screen just for convenience. So let's paste it here so that I have reference for it. Okay. So as you can see, the first equation, my gradient is. Now I won't use m just so because that's confusing to solve my m. The gradient here is -3 on m. The gradient here is given by, and you need to combine these two fractions because they're both x's. You should get negative m, -2 over 5 if you combine the x. So -2 over 5 x on 5. Okay, so bit of a step there, even the calculator will simplify for you. The y-intercept is my c value is 5 on m in this case, and my c value is m on 5. Now, once I've got my gradients and y-intercepts for each line, I can do the calculation. So my first calculation is for infinite mean solutions, I want the gradients to be equal. Okay, remember, two lines are the same, the gradients are equal. So I want to make this gradient up here and this gradient equal. And I want to solve for m. I want to find a circumstance or the value of m which makes them equal. Okay, and you'll find there's only particular values that this occurs. So go fraction tool, -3 divided by m equals fraction tool -m minus 2 over 5. And I'm going to go interactive and solve because I want to solve for m. Interactive and solve for m. I think I pressed the wrong button. Interactive and solve for m. So variable m. And you see m equals -5 and 3. Okay. So m equals -5 and m equals 3. We want the same c value. Okay, we want the same y-intercept. So you want to make this and that equal. And we see what m values leads to the same y-intercept. So I'm going to go interactive and solve again. So 5 5 divided by, I'm going to use x just for convenience, so that I'm not wasting time finding m, interactive and solve. And we see m equals -5 and 5. M equals -5 and 5. Now, we've got to do some analysis here because we've got our solutions, possible solutions. So we've got m equals -5 and 3 for the gradients equal, and m equals -5 and 5 for the y-intercepts equal. Now, let's look back at the question because it says we want infinitely many solutions. So for part A, maybe I won't do this. I'll do here part A. We want gradient to be equal. Okay, so there's two possible values for the gradient to be equal. M equals -5 and m equals 3. And we want the y-intercept equal. So -5 and 5. Can you see that they both have -5 in common? So if I choose m equals -5, that actually satisfies the condition of both the gradient equal and the y-intercept equal. So it gives us infinitely many solutions. Whereas for part B, we want the gradient to be equal, but we do not want the y-intercept to be equal. So we can't accept m equals -5 because if that's the case, then both will be equal. So the only option is if I choose m equals 3. And the reason why I choose m equals 3 is because if m equals 3, the gradient will be equal, but the y-intercept won't be equal because nowhere in the solution for the y-intercept is m equal to 3. Okay, so the only option is m equals to 3. So hopefully that clears your understanding on this type of question. It is a bit complicated and it does involve a lot of steps, but like with anything, you just got to think carefully about what I'm trying to achieve here. Okay, so analyzing our m values.